Thank you very much. It's always nice when they have the background music because it makes you feel like you're a celebrity. You have walk-on music and whatnot. Oh, shoot. I'm very loud. You probably want to turn this down. I'm David Aronchick. I'm co-founder of Bacalhau, and I'm a huge fan of Wasm. We've been coming to this conference for several years. You may have seen us a few years ago. And I'm just so impressed with how far the community has come. And in particular, like how much Wasm is advancing and has all these great components and things like that. I'm kind of going to work on something that is very much not Wasm. It's like the end of every one of the advancements you saw today and over the past 2 days. Once you now have your Wasm and it's running and it's looking great, what do you do with it? And I'd like to start with a controversial statement. So you in this audience, you on the video, are probably doing infrastructure wrong, at least somewhat. And the reason is because there's such a standard for the way that people do infrastructure. They think about it as compute, right? Basically, like how many machines do I have on this cloud? How where have I deployed? What OS version is it? So on and so forth. If you're really lucky, you're doing something around DevOps and you're rolling things out in a more fixed way. And you have binaries associated with that, with GitOps and other things like that. I would like to suggest that not including things like data placement, and so on, is really a big hole in a lot of these infrastructure deployments, because it's not just about deploying these binaries and getting it to a certain place. It's also about including it. And when you think about your Wasm binaries and so on and so forth, it's not just about where you're placing this application. That's kind of the easy bit. It's once it's out there, how do you know it's running? How do you know the configuration is there? How do you know it's receiving the right data or producing the right data, so on and so forth? And we'd like to kind of help address that problem. I start with a fairy tale. You all probably have experienced something like this, where you have your developer and she comes up with something really cool. The application looks great. She's ready to roll it out. That's awesome. Your infrastructure looks maybe something like this. Maybe it's a little bit simpler, but if you're doing things right, if you're doing things according to the way the hyperscalers suggest, you're doing things multi-zone, multi-region, maybe you're already doing it multi-cloud or on-prem as well, and your infrastructure is everywhere, and the developer's like, this is great. I'm done. Throw it over the fence, and your SRE is very unhappy with this. Right? And the reason she is very unhappy with this is because rolling out distributed applications is very hard. When I posted this to Blue Sky and asked people what problems they had actually seen about this, this was a list they came up with, and it's not even close to being a complete list. Right? These things are challenging. It's so easy to get this stuff wrong. Or maybe it's none of these things. It just doesn't work. Right? And you don't really know why. So what do you do about that? How do you reliably know how you rolled it out, where you rolled it out, and so on? Now, a lot of people are like, well, I am using ML. It's not really the same thing. No, I am telling you. I was lucky enough in between working on Kubernetes and now to start a machine learning platform called Kubeflow. I have a ton of experience with this. Like, people who treat models and AI and ML as anything other than your average application are going to try and reinvent things that people have been understanding for many, many years. And I encourage you to walk away and say, models are just applications. So don't think, oh, it's a model, I need a brand new tool chain. Nope, don't do it. Reuse it. So then you're like, okay, well, maybe I'm not going to do it distributed, right? I'm going to do it by creating a very, very big machine. And on this machine, I will have everything that I want to have it rolled out. But the reality is that's still not going to cut it, because you're still in a situation where you're effectively distributed, right? I like to say, once you have introduced an Ethernet cable, congratulations, you have a distributed system. And if you do not treat it as a distributed system that can fail for any one of these reasons, or many more, you're going to have a problem. And Wasm is no exception. You're going to run into these problems over and over again. You finished your build, you finished your binary, it runs great. Even the local integration tests run great. How do you get it out there to these places? And worse, remember what I said earlier about data? A lot of times, the reasons that people have so much trouble around this is because data. They're like, well, I'm just going to centralize it all and put it in a data lake. But you have all these challenges around first moving the data into a data lake, or then after you move the data into a data lake, how do you deal with all those problems as well? And so as you're thinking about deploying these applications and these great Wasm binaries and all those features you saw today, thinking about how you deploy things in a distributed way where you are treating your infrastructure and your compute and your binaries and your data as a holistic set of descriptions that you can use to roll things out is incredibly important. And I know what you're going to say. I'm very smart. I'm just going to use Bash. Bash is amazing. Bash is amazing, by the way. It's like 50-year-old technology at this point, older than me even. And it's fantastic, right? Except here, right? What if you have a bad network connection? What if you only half rolled out? What if you want to know it did roll out, but it's still running? How do you change a configuration? All these various things. These are all things outside of the technology that you have heard for the past 2 days. It's not about that binary. The binary runs great, but now you need to get it out there to the rest of the world. And there's so many problems that you end up having here. And my encouragement is don't try and reinvent the wheel. And the reason why is because this is how you kind of approach the problem. And when you think about that data problem, that thing that everyone's already ignoring, it is just getting worse. Every day, we are producing more data than ever before, 175 zettabytes worldwide. And even if you had ubiquitous data everywhere, I'd like to say the speed of light is not getting any faster. Right? You will always have challenges moving data around simply because of distance. And that is not that's assuming you have no other problems, which I promise you do. You do have other problems. So that's a lot. And what I would like to propose is an architecture where it addresses the modern path for modern data processing. Keep using all those tools you have over on the right. For all your binaries, for all your data, for all your infrastructure, they're still great. I promise you, they're awesome. But think about an overall infrastructure which treats the things on the left-hand side just as importantly as the things on the right. And that's what we're trying to propose. An architecture called compute over data. Now again, we are not new here, right? This is as old as time. The number of times I go in and talk to a customer and say, yeah, you know what? I did that very thing when I was in university 35 years ago is very large. They have deeply integrated systems into their overall infrastructure that's at the largest hyperscaler all the way down to your smallest individual. They have systems and ways for doing compute over data, running remote compute jobs. But they often are going to run into those same distributed systems problems more than ever, and especially in things that are so portable, like Wasm, you're going to run into this over and over again. So about 3 years ago, where we were here, shortly before we presented here last time, we were in Portugal, and we came up with compute over data, and we're like, hey, we really need to get at this. We kept abbreviating it as COD. When in Portugal and you keep abbreviating something as COD, you name it Bacalhau, right? And that's the name of the project. It is, like I said, about a 3-year-old project, millions of downloads, community. We have weekly meetings and things like that, all around how do we help people embrace these architectures. We also, by the way, I should say, and this is, I think, the only commercial component, have formed a company around it called Expanso, designed to support customers who are looking to embrace these environments and adopt the open source project. Our goal with Bacalhau is to help you process your jobs in place without moving data and limiting your overall leaked information. And I'll show you exactly how this works in just a minute. But the way I like to say is, if you know Kubernetes, or you know any internal system, and this could be Spark, or Hadoop, or, like I said, Kubernetes, Docker, Swarm, whatever, they are amazing. Keep using them. Remember that right-hand side of the slide? Keep using those orchestrators. They're great, but they are great for a single data center only, or a single zone, usually only. The moment you start to think about things that are going cross-zone, cross-region, cross-cloud, that's when it starts to think about other architectures that work, and that's where Bacalhau fits in as a complement to these solutions. Some of the key scenarios for compute over data and Bacalhau, transforming data before you move it, executing over poor networking, and using data in isolation. I'll breeze through these pretty quickly. I'm more than happy to talk about them. But transforming data before moving, I like to say, like, you have all those orchestrators on the right-hand side. They're great. On the left-hand side, you have this data being generated by servers, and it's usually not just one server. Usually it's many servers. And you have all those problems that you normally run into when moving that data. And you don't want to move all the data. You only want to move subsets of it. This can be very, very challenging. Real-world customer scenario is where people are collecting video, for example, and they want to do processing over that video, identify if there are human beings, count things, so on and so forth. This can be very good, but it's also very, very large. A customer that we're working with calculated to be about 4.4 petabits a day of video data movement. And instead of moving it, what do? They have human beings go and look at these things and then throw the data away after about a week, right? Which is really not ideal. Bacalhau and compute over data can help by doing processing near where that data is being generated. You can scan it, you can create snippets, you can do all kinds of stuff like that. Second is around executing over unreliable networking. Again, you saw so many examples over the past 2 days of people doing really creative things, on drones, on devices, on edge, multi-data center, multi-zone. And the problem is that these situations, normally you could just connect to them. But more often than not, the connections are intermittent, right? This is how TCP was built, to be intermittent and recover. But that's not what orchestrators are built for. They want a super regular heartbeat. If there is a network partition, more often than not, your data is going to go sideways. And Bacalhau helps address this directly. We execute over poor or unreliable networking. And I'll show you how we do that in just a second. And then third, using data in isolation. So lots of folks want to execute over data that never moves. And the reason they never want to move it is because they are regulatorily bound. Could be state-related, things like GDPR and government regulations. Could be due to privacy or other sensitivity concerns. But Bacalhau helps you do that as well, because we help you roll out, and compute over data helps you roll out to these locations without ever potentially moving your data. And I'll show you how we do that in just a second as well. So you still might say that's not you. You have none of those problems. But as people who go and centralize all their data into a central API, I promise you are going to have a bad time at some point or another. And this is where you really get into leaking. The more that you end up putting this in a single place, the more risk you're putting your data at. Centralizing raw data will always be a risk. And again, just like that speed of light, this is an immutable truth. So don't do it. The suggestion is this is slow, it's costly, it's insecure, it's unreliable. Use your data and applications everywhere, and this is what Wasm is perfect for. To show you what a job looks like, who in the audience knows what Kubernetes, what a Kubernetes job is? Roughly. Okay. So not everyone, but there are enough that know. And as you see here, this is very similar to Kubernetes job, right? We were deeply inspired. This happens to be YAML. We of course accept JSON or anything else like that. But it's really straightforward. It's just like, here's the engine I want to run with. Here's the parameters I want to run with. Go figure it out. And that's what we go from there. And just by doing that, it enables you to run multi-zone, multi-region, multi-cloud, all those things. And so whether or not it's in multiple locations, on multiple types of devices, on low power or embedded devices, we make it easy for you to run those jobs in that greatly distributed way, sitting in front of your existing infrastructure. And then simply by doing that, you reduce the overall amount of data that you move from those remote locations into a central repository, making your overall system faster and better. Okay, so I've said a lot of things. Let's go to the demo. This is a live demo, so you'll please bear with me. I've been having terrible networking problems today, but we'll see if this works. It is also public, so you're more than welcome to go up, fork the repo, and go. I'll have links at the end that you can follow. But I've created a simple dashboard here. This is a dashboard where I have about 30 simulated sensors running in a given region, in this case, the US. So what I did here was I communicated with the Bacalhau API in the self-hosted Bacalhau API, and just said, I'm going to go provision this. You figure out how to provision this. Every one of those sensors is sending a note every second, and it's collecting those and presenting them. So now, if I take this, and so just to show you what a job looks like here, really straightforward. It's just a YAML. And I can show you what this job looks like, real live in line here. And there you go. So like I said earlier, it's just, at the end of the day, it's just a very, very standard job, a bunch of YAML. And if I go and deploy that job, now I'm deploying and I'm communicating with the single distributed system. And behind the scenes, it is sharding it out to all the nodes that match the label. So if I go back to that job, you can see right there at the top, is there a laser thing on here? Yes, awesome. I love it when they do that. So you can see there's a little label, and it says where this is going to go, and it places that against the Bacalhau API, and the Bacalhau API says, okay, what nodes have identified themselves as being a placement target for this? And that's what this does. So now if I go back over to my dashboard, I will see the EU has now been deployed, right? So now I have 30 more sensors running in the EU, and I'll do it again, but this time I will show you it deploying live. And I go here, and this time we're going to go over to Asia and do the same deployment. Off it goes. Oops, don't need to see my Slack. And so right now, again, it's placing those nodes, it's downloading them, and it's going to place those jobs. And forgive me that it's going to take just a minute to come forward here because it's pushing these signals constantly. Actually, we have a feature. Oh, there, it beat me to it. So you can see it went down, provisioned that. Each one of these is a brand new Wasm job being deployed into that location on a node. And I don't have my little visual aid. We simulated a Raspberry Pi. It's about that big. And of course, we're doing it on the cloud. These aren't actually Raspberry Pis, but you can see that there. And so you can see how easy it is for me to deploy across these various regions. So now, again, you can do that elsewhere, but what happens when I want to do something like, for example, update a job? Again, this would be a challenge to select across a given region or across something specific, but here, we make it incredibly easy to, again, pick your label, pick your job, and go and place that. And what you'll see here in just a second is that I've selected a given region to do a deployment to, and the US will very quickly, well, what do you call it? I'll speed it along here because we do have a clear Q button. Is it working? I guess not. All right, but suffice to say, behind the scenes, it is placing it. Oh, is it? Yes, it may not be coming up there, but you can see that some of them are starting to turn more purple. And that's because the example that we gave here was that it was changing from red to purple. We can also, we're very resilient here. And so if I want to, for example, disconnect an entire region, we can do that. Again, this is just behind the scenes. It's stopping these various, it's actually literally stopping the Bacalhau node running in those various locations. These are deploying Wasm jobs. That does not stop the job from running, right? We're just simulating disconnecting the orchestrator from the job. And the reason I'm doing that is because now I'm going to deploy to that now disconnected region, and it's going to run fine. The website is still running fine. The jobs are still running fine. Everything is running normally, except it's now in disconnected mode. And when we decide to reconnect it, we can do that here. And those, all those nodes, those Bacalhau nodes, not the underlying Wasm jobs that were sitting there running, are now redeploying and starting back up. And then behind the scenes, we will see in just a moment, again, this is taking a little bit, but we'll start to see the EU start to light up. And again, that was without errors, without any polling, without you having to do some complicated system where you had to understand what it meant to roll things out in a distributed and reliable way. Our goal here is to make it incredibly easy so you can focus on your applications, and it will handle all the problems of only once delivery and eventual consistency and so on and so forth. That's what Bacalhau provides. Very, very lightweight and can run in your system. And then as you can see there, now that we've reconnected the EU, those jobs and that updated deployment are now beginning to roll out. Okay? So, what we would like to say is that Bacalhau, again, it's not to say that it's the only way to do it, but what you saw there was real deployment of these jobs in volume, even over very lightweight solutions. So then you're like, okay, deployments are one thing. What else can I use it for? I like to touch on these 3 ones where I see people running into this all the time. A lot of times people have things like a distributed data warehouse where you might have hundreds of thousands of IoT devices or retail or even just regular servers in many locations. A lot of times the data is very poorly structured or so on. And what you want to do is have a data warehouse and get that data into your data warehouse, but you want to do some initial processing before you do. That's where an architecture like Bacalhau and compute over data can help. What we do is we advise people to have local data warehouses or local iceberg tables that they can run. Bacalhau helps manage the state and does distributed queries across those with streamlined data ingestion and overall reduced costs. So if you are running into challenges where your blah, blah, blah vendor bill is too large because you're taking all your data and injecting it raw into your data warehouse, I like to say we can save you, double-digit % within the first week that we deploy. And if your developer would like to do ad hoc queries against that as well, we can help you execute your job against that and then deploy it to those various locations. Optimized data pipelines, this is another one. We get to that raw log example. And again, I'm not bad-mouthing any of those log providers, but this is often how people take their data. They just inject it into that very central location. This is extremely costly. And like I said earlier, insecure. The extent to which you can take action more quickly because you're getting faster answers is super powerful, and often that is compelling enough, let alone the amount of money that we can save you. And so what you do is instead you run your data processing jobs on or near where you're producing that data. You continue to move it into your existing data pipeline, and all of a sudden, magically, you're just saving money and getting much, much faster answers. And we can do this for you because we don't require any new SDK. We don't require any kind of new things. You want to run it with Python or sed or grep, knock yourself out. And by just doing it that way, we can show you how to move your data to archival storage where it doesn't sit in that extremely costly intermediate bucket. And then finally, around securing data. So again, this is where compute over data as an architecture really shines. More often than not, if you're doing data pipelines, you are out of compliance because the moment you move that data off that original device, you run into compliance issues. What we like to do is we like to say, you know what, in your zone, in your region, this is the place to go and do your deployment. And then from there, you move only the compliant data through. Again, something that's extremely relevant for folks using Wasm and using these things that are extremely distributed because you want to be very thoughtful about the kind of data that you're moving off device. And by the way, we do audit logging. Every single action you've seen here is provided with a write-forward audit log, and we give that to you kind of for free. And lots more. I can talk about this till I'm blue in the face. Lots of questions. Well, I like Kubernetes. Do you support Kubernetes? And I'm very proud to say we do. We have a Kubernetes CRD. You take that job, that I was demonstrating earlier and basically put the entire job, copy and paste it into a Kubernetes job, and it just magically works. Now again, almost. There are a few edge cases where there's some challenges, but most of the time it will run great. And the way it does this is by starting with the Kubernetes API, it passes it through, you set up a Bacalhau cluster, and then go from there. Let's say even though I'm at a WasmCon, I feel remiss if I didn't mention, let's say you love Docker, or sed, or jar files, or I have no idea. Do you support that? Yes, we do, right? Natively, we have a pluggable executor that supports Docker, or sed, or jar, or take your pick. We don't think it's infinitely pluggable, but we haven't seen someone who's said, I don't know how to use your system. It is extensible. You can run it yourself. You can use the ones that the community has built. It's up to you. And then you say, OK, but I'm extremely on-prem. Is this cloud specific? And I want to give you a little quick demo of a very, very silly example that I hope will show you how super flexible we are. If I go over here and I go to my other screen, in my demo here, this is how easy it is to get a node started. Okay? So this is my local machine that is a real live cluster. We have a cloud. It's called Expanso Cloud. It's not the core of our business, not remotely. Most folks use us entirely in an on-prem way. But it's a nice way for people to get started, right? So here you go, just to show you nothing up my sleeve. I have no nodes running. If I go over here and I start a brand new job, this is my local machine, this Mac sitting right here, who is executing a job and joining this global network. Again, and by global I mean it's private to me, but it's just running. Okay? So far, so good. So now what do I want to do? Well, let's say I have a very private file that I want to run. Okay? And again, I'll just show you right over here on the left-hand side. You can see here I have just 4 files in that directory. And what I want to do with this file is encrypt it. Right? It's very secret. I don't want to move it into a data lake. I don't want to do anything with it. It's sitting on my Mac. Again, silly example, but just to show you the power of it. And I have this public key here that I will encrypt it so that I can get it later. How do I do that? Well, what I have here, and forgive me for using Docker here. I literally, until minutes ago, was trying to get Wasm to compile the cryptographic binaries. I couldn't get the libraries to work right, so forgive me. I'm using OpenSSL. But this, as you'll note, this is just the generic OpenSSL that you can get anywhere, right? And what I'm going to do is I'm going to run this job. I'm going to hand this job to the cloud, right? Some public cloud out there. And it is going to schedule that job to my local machine to do this execution. And what it's going to do is it's going to take that public key, the beauty of asymmetric encryption, and it's going to encrypt it locally and create a new file on my local machine. And it's going to do that without sharing any of the data anywhere. So to do that very complicated task, all I do is the following. Bacalhau, job, run, boom. Okay? So again, just to give you clear what's going on here. It's going up to the cloud. It's finding a machine that matches the label that I have given to it, which happens to be this machine and this machine only. It's scheduling a job down to this local machine. It's running that encryption job locally, and then it's saying it's done. Now, when you see it is done here, I have a full audit log that this job actually was executed, but you can see nothing else is there. I don't know any about the data. I don't know what file was executed. I don't know anything like that. That all happened locally. But when I go back to my job here, you can now see I have an encrypted text. Okay? So right there, again, completely privately, that is the beauty of compute over data. And again, in any other world, I would have gotten the cryptographic binaries running, and this would be Wasm doing this, not Docker, but I hope you bear with me and trust that I actually could get it going. Again, cryptographic libraries be damned. And oh, by the way, here's on the cloud. You can see here, here's that cloud instance that I had there, and now I have one node running, which happens to be the node that is this very local machine. OK. And with that, like I said, the summary is Compute over data is not new. It's old, but it's new again because data is getting so big. Non-centralized stuff is just as important, maybe more, than your massive data centers. And flexible architectures that support so many different configurations and deployments and things like that is what's critical. Because the less you have to have people change the way they do their things, the more likely you're going to get to adoption. Bacalhau is open source, as I mentioned. We have community calls, we have quarterly workshops, monthly newsletters, we got a Slack channel with 1,000 people in it and so on. And that's basically it. You can see all your information there. I have negative 13 seconds for questions if anyone wants to ask me. And of course, I'll be here for anything else. Questions, comments, anything? OK. Well, thank you so much.